Hello, everyone. It's good to present this lecture on a topic that I really like and enjoy to discuss. My name is Karla. I'm a senior teaching fellow applicant, and I hope you enjoyed this presentation. Today, I'd like to discuss with you mediation and moderation effect in clinical research, why it's important and how could we test, and why should we reflect on these topics when we are planning research. So the objectives for this presentation, I'd like to first start with the definitions of mediation and moderation effect. To reflect on how we can test for mediation and moderation effect and discuss why it is so important to think about and test for the presence of mediation and moderation effect. So let's start. Mediation. Mediation is something that will help us to understand the factors that are within the causal pathway between the treatment or exposure and the outcome. So if we're thinking in some exposure, for example, smoking and lung cancer, we should think that maybe if there is any mediation effect, there is something within this pathway, causal pathway. The other topic is moderation. So what is moderation? Moderation is the moderation assessment will help us to understand in which circumstances or which characteristics that might change the treatment effect over the outcome. So it's something that will change the influence of the exposure or a drug or an intervention on the outcome. Importantly, mediation and moderation analysis go beyond group level analysis. The on average effect, especially with moderation, we are not interested in the on average pool group effect anymore. This is especially helpful in complex and heterogeneous population. Why? Because especially in this heterogeneous population, we should expect that a drug or an intervention will act differently in different population or subgroups. So we are starting here with one variable, one independent variable, drug, surgical procedure, or non-pharmaceutical intervention or exposure on the outcome. So there is a direct effect. If this is true, a simple linear regression or t-test assessing this independent parameter over the dependent variable is enough. However, it's common to imagine that in clinical research, epidemiology, it's not that simple, and we should think about other factors that may influence this relationship. And here I'm starting with the mediator. So as I said before, mediator is something that is between in the causal pathway between the independent variable, our exposure or intervention, and the outcome. The other one is the moderator. The moderator will affect this relationship between both parameters. It is not related with the independent variable or our predictor or exposure, or it's not related with the dependent variable, our outcome, but will directly affect the influence between these two parameters. But why does it matter? So this is an important question, right? Why should we care about this? Why? Because the identification of mediation and moderation effect will help us to improve precision medicine, because we can identify different effects of some drugs in different populations and individualize effect instead of focus on average effect. That may be not true for everyone, right? And help to avoid the one size fits all idea. we are so complex. Human bodies are so complex. Why should we think that one drug will act will have the own average effect in everyone? So let's start with some examples. Mediation effect. It clarifies the mechanism of action involved in the outcome development and disease process. So it helps the identification of the mechanism of the disease, which we know that this is important for clinical research and research question developments, right? For example, depressive symptoms can mediate the effect of income and sleep pattern. So if we assess a linear regression having income as predictor, as exposure, and sleep pattern as our outcome, if depressive symptoms has a mediation effect, we can't add these in the linear regression models, and I will explain why. So here you're seeing that depressive symptoms is in the causal pathway. And now let's reflect on an example of moderation effect. Moderation effect identifies a subgroup change. A subgroup changes on the treatment effect over the outcome. For example, ethnicity or socioeconomic status will influence the relationship between depressive symptoms and memory. If this is true, we cannot consider the pool effect anymore, because one subgroup will have a different effect of our predictor on our outcome. So here the socioeconomic status will influence this arrow between our exposure, our predictor, and memory performance. So in the settings of lack of socioeconomic status, we find one effect. And in the presence of socioeconomic status, low or high, depend on how you treat your variable, how you coded your variable, it will change the effect of depressive symptoms over memory performance. So in both cases, the commonly used adjustment for confounder or covariate adjustment is not appropriate. It's inappropriate to include a mediator in a regression or any model. And it's also inappropriate to treat a moderator as a confounder or covariate. But let's reflect or review these concepts. What is a covariate? A covariate is a variable that affects the outcome, but does not affect the independent variable. And a confounder is a variable that affects both the outcome and the independent variable, but does not drive the relationship between both. So does not affect the causal pathway. So seeing the complete graphic with all the variables included, it's not common to have all in one model, and in fact, it's not possible to assess all this relationship in one model, but I want to put everything together because you can see all the parameters. So we have the mediator between independent variable and dependent variable, the moderator affecting the relationship between both, and the confounder in brown and with the dashed arrows showing that confounder will have a relationship between the independent variable and dependent variable, and the covariate. The covariate here only affects the dependent variable. One recommendation regarding covariate adjustment is sometimes that you should adjust for covariate because you reduce variability of your model and increase precision. But anyway, we can discuss this in another lecture. But importantly, if we consider a variable as covariate or confounder, it cannot be a mediator or moderator. meaning that if we consider something as confounder and covariate, we can include in our model to adjust for it, but a moderator and a mediator should be treated differently in the model. Let's discuss a little bit more the mediation effect. So as I said before, we want to understand the factors that are within the causal pathway between our treatment or exposure and the outcome. But why we can't adjust for mediators in the model? Basically, it is because we would remove key elements of the causal pathway in the model. If we adjust for depressive symptoms, we would remove important causal effect from the model. So how should we treat it? So one possible evaluation for mediation effect was proposed by Barron and Kenny in 1986 and suggests a 4-step approach. Basically, in this relationship, we cannot include everything in a model because if we consider the depressive symptoms, the true causal effect in this relationship, we should include depressive symptoms as exposure and sleep pattern as outcome. If we test depressive symptoms as mediator and we cannot prove that it has a mediation effect, but we believe that could be a covariate, we can include and adjust in the model. But let's discuss this 4-step approach. So in the mediation analysis, we basically will run 4 different regression models. The first one, we will assess a simple regression analysis with income, our example here, our independent parameter here, predicting sleep pattern, our outcome, and test this pathway. So it's a simple pathway with one independent parameter and one outcome. The second step, we would keep our exposure as income, but we would test if depressive symptoms as outcome. And these would be our second second step. So we would try to predict depressive symptoms by the outcome, our independent parameter. The step 3, we would conduct a simple regression analysis with depressive symptoms as exposure to predict sleep pattern and test again this simple pathway. And the fourth step would be a multiple regression analysis with outcome, the income as predictor and depressive symptoms as covariate, predicting sleep pattern. Here, a multiple linear regression. And let's interpret these steps and this strategy to identify the mediation effect. First of all, we run the first 3 steps, step 1, 2, and 3. If one of these is not significant, there is no support for mediation. So probably depressive symptoms was covariate or even confounder if we see like this, and we can use in our model to adjust for it. But if the steps 1, 2, 3 are significant, there is a statistical support for mediation effect. This means that depressive symptoms probably are in the causal pathway between income and sleep pattern. It is necessary to move to the 4th step. So moving to the 4th step, if income, our exposure in the initial model, lose statistically significant association with sleep pattern, we can say that there is a support for full mediation of depressive symptoms. So all the sleep pattern is explained by depressive symptoms and not by our income, our initial independent variable. On the other hand, if income is still significantly associated with sleep pattern, and depressive symptoms is also associated with sleep pattern, there is a support for partial mediation. So probably both are in the causal pathway, and the presence of the sleep pattern is explained by both predictors, by both independent parameters. So here we are with our initial idea. The step one is basically the regression between income and sleep pattern. The step two is income and depressive symptoms. And the step three is our third model, third simple linear regression model, assessing the association between depressive symptoms and sleep pattern. And the fourth step, if we see significantly association in the three models, we go to the step 4, basically assessing depressive symptoms as covariate. And the interpretation was basically, if income lose significant, we can say that only depressive symptoms explain the sleep pattern. But if both are significant, the both factors are in the causal pathway, and there is a partial mediation effect of depressive symptoms. Okay, now let's move to the moderation effect. Moderation, as I said before, will help us to understand which circumstance or characteristics might change the treatment effect over the outcome. So different ethnicity, different race or sex, thus these specific subgroups, we can see a different effect of the treatment or the exposure on our outcome, disease progression, mortality, or any other outcome that we would like to investigate. It identifies if there is a group that presents a more beneficial effect by the treatment in comparison with others. So in my example, I use depressive symptoms and its association with memory performance, and having socioeconomic status, low versus high, as a moderation effect or effect modifier. You can see this term in the literature too. And to test moderation effect, you need to create an interaction term in the regression model, and it will be basically regress your outcome, the predictor, the moderator, and the predictor and moderator interaction term. This will test the effect of the exposure or treatment with and without the moderator. If the interaction term is statistically significant, we have support for moderation effect. Again, another important conclusion is, if there is a significant moderation effect, the pool or group effect is no longer true. And subgroup analysis with a carefully interpretation should be described. For each group, we should expect a different effect of my treatment. And here, the regression equation, the interaction term, basically we conduct a regression analysis with depressive symptoms predicting memory and adding the interaction with socioeconomic status and depressive symptoms in the model. Interestingly, if socioeconomic status is low, coded in 0 in my model, we would have a model that is represented basically by our outcome, is the intercept or our constant in the model, plus the beta 1, the coefficient for our treatment, times the coefficient in the model, and that's it. Because all the moderation, the moderator variable will be excluded because it is coded as 0. On the other hand, if for example, high socioeconomic status was coded as 1, my equation would keep all the moderators in the model, and these would affect the final outcome. So that's why we have this change when we include the interaction effect. And I always suggest write down the equation to interpret any regression model. It will help a lot. Another example, younger individuals might lose more weight when exposed to a diet in comparison with older individuals. And why should we expect this? The body, all the metabolism change with age. So we should expect some difference on treatment effect in different groups. So that's why moderation effect is so important. In this example, it's just a fictional example. For example, patients younger than 40 years old, the weight loss was 8.7 kilograms after starting the diet, and for patients older than 40, this weight loss was much reduced or smaller, 3.1 kilos. So again, age categorized as younger than 40, older than 40 would change the effect of diet in patients. And this is an example from the literature. This was a randomized clinical trial with 2 groups, placebo groups and topiramate groups, assessing the heavy drinking days per week. And we can see a clear effect over time of topiramate over placebo group. So a reduction in heavy drinking days. However, in the interaction, in the moderation analysis assessing subgroups, it was clear that assessing different genotypes, CC, AC, and AA genotype, this difference was only present in the CC genotype group. And in fact, it was a strong effect. However, in the group that has in the 2 groups that have AC genotype and AA genotype, the effect was minimal or no effect. So the precision medicine is a very relevant use of moderation effect, but importantly, we need to have some mechanism of action or base previous literature that support these hypotheses. And that's it. I finished my presentation. I would be very happy to hear your feedback, questions, suggestions, and this was the papers and literature that I used to prepare this presentation. Thank you so much.